All right, so in part 2 of this video, we're going to try and derive the distance formula. So although this method you learned for finding the distance between 2 points will always work, it's not practical for to plot points on a coordinate plane and draw a right triangle every single time you want to find the distance between them. Okay, so instead we're going to use an algebraic method to derive a formula for finding the distance between any 2 points on the coordinate plane. So we're going to start with any 2 points, x1, y1, because it's our first ordered pair, and x2, y2, our second ordered pair on the coordinate plane. So for example, I drew 2 points and drew a line in between them. So we're going to visualize these points to draw a right triangle with a horizontal leg and a vertical leg. Okay, so back I have my horizontal leg here and I have my vertical leg up here. So on number 11 it says, what are the coordinates of the points at the vertex of the right triangle? So it wants me to come up with an ordered pair to represent this point. In our last problem, I believe it was R. So how we would do that is when I had 2 horizontal lengths and a vertical length, I subtracted them and took the absolute value of them. So let's kind of go back to a problem we just did. So to find this R value, I subtracted these lengths. To find the R value to begin with, my bad, we noticed that the X values were the same in the vertical line, and then the Y values were the same in the horizontal line. So that's going to be true when I derive my formula. So over here, I'm going to have the same X value. So my first order pair is going to be X sub 2, and then I'm going to have the same Y value over here, Y sub 1. Okay, so this point over here for some general formula, it's going to have the same X value and then the same Y value over here. Okay, so the coordinates are going to be X sub 2, comma Y 1. Okay, then I'm going to write a general expression for the horizontal leg. So I kind of talked about that already. We subtracted our X values to find that horizontal distance. So for example, the horizontal distance here was a 12, and the reason I got that was doing 13 minus 1. Same thing for this Y value. I would subtract these two numbers to get a 5. So subtracting your Y values there. So let's do that over here. So if I wanted to find this horizontal length, I'm going to subtract my X values. So I would say x2 take away x1. So that's going to give some expression for the horizontal value. All right, same thing up here. For my vertical length, I'm going to subtract my Y values. Doesn't really matter which one you subtract. We always like to subtract the Y one first. Okay? All right, so now I'm going to use the Pythagorean theorem to write an expression to find the hypotenuse. So remember I did a squared plus b squared. It didn't matter which one was first. So I'm going to say, I don't know, leg. So I have my a squared, so I'm going to say x2 minus x1 squared. The reason I put those in parentheses are because I have 2 values in there. So x squared plus a squared plus b squared, so is my other value, y2 minus y1 squared. That's going to equal some c squared value. Okay? All right. So again, I just found an expression for the horizontal distance and an expression for the vertical distance based on my knowledge of what we just learned about how to find the distance between 2 segments. And then I substituted them into the Pythagorean theorem. So now if I wanted to get c by itself, we know we would square root it based off our thing from yesterday. And so that is actually the distance formula. So the distance formula equals, if you take this big long square root of all of that. So I'm going to write a very long square root. And then go ahead and copy down x2 minus x1 squared plus y2 minus y1 squared. Boom! And that is the distance formula. That will work for any 2 points, and you don't have to graph anything. You can just substitute in numbers. Okay? So this is what happened many, many years ago when they were trying to find the distance formula. They played around with finding it in general terms and then figured out this worked for every single one, which is so cool. Okay? Good news and bad news. You are going to have to memorize this. So the good news is it kind of looks like the Pythagorean theorem. So you've got some a value squared plus some b value squared equals c squared. And the reason it's square rooted is because they had to get rid of the squared. Okay? All right, so let's take a look at some practice with using this new formula that we derived. All right, so 16 says, use the formula you just wrote to find the distance. So I always rewrite the formula to help me out. So distance equals big long square root, parentheses, x2 minus x1 squared, my a squared plus my b squared, y2 minus y1 squared. Okay, so now I just substitute in. And so this 12 is my x1 because it's my first x. This 5 is my y1. It's my first y. Negative 3 is my x2. And 7 is my y2. Again, order doesn't matter. You could have these flip-flopped. As long as you make sure this 12 is your x value, the negative 5 is your y value, you will be great. So let's substitute in. So I have d equals per square root, parentheses. My x2 is this negative 3. So I'm going to write negative 3. I always bring down this minus sign. Always, always, always. My x1, sorry, is 12. Close it, squared. So I have negative 3 minus a 12 squared. Then I'm going to write a plus sign. My y2 value is a 7. I'm going to bring down this negative sign always, subtraction sign. My y1 is a negative 5. So I do have to write that negative again. Okay, and here's where it gets tricky. So there's always going to be a subtraction problem or a sign on your problem. And then if your y value is negative, something fancy is going to happen here because we know two negatives make a positive. Okay, so I'm going to go ahead and make this into a big plus sign. Okay, at this point, if you wanted to type the entire thing in your calculator, we could. So I'm going to show you how to do that. Let's pull up our handy dandy calculator. So to find the square root button, you're going to have, it's going to be right here, it's in blue, above the x squared button. So that means I have to hit the second button first and then the x squared button to get anything in blue to come up. You're going to start with your parentheses. Make sure you guys are doing this with me on your computer. So go ahead and type negative 3 minus a 12, parentheses, and then the squared button is right here below that x squared button. Make sure your square root sign is going all the way over your calculator right now. If it's not, it's going to give you an incorrect answer. Plus, parentheses, 7 plus a 5, close it, squared. Okay, so notice my square root symbol came all the way over it. If you hit the enter button, that is our final answer, which is a, oh gosh, it went away, 19.2. So the distance between those 2 points is about 19.2 units long. Okay. I will also show you how to do this if you did not want to type it all in the calculator. So if you didn't want to do it in the calculator, you would simplify it by hand. Negative 3 minus a 12 is a negative 15 squared plus 7, 8, 9, 10, 11, 12 squared. Anytime you square a number, that is always going to be positive because when you square it, it is multiplying it by itself. So this is basically saying negative 15 times a negative 15, which is a positive. So 15 times 15, I believe it's 225. Let me check. Yep, 225 plus 12 squared. 12 times 12 is 144. When you add those two numbers together, you will get d equals the square root of 369, which gives us that magical number of about a 9.2. Okay? So that is how you use the distance formula instead of graphing. So instead of graphing these 2 points and drawing a right triangle and finding the distance and doing the Pythagorean theorem, you can just substitute in. It is a little, you have to pay attention to detail. You can mess up on your negative signs, your positive signs. But once you do get to this step, you can just type it in the calculator. So if you like that, go for it. Okay. I am going to show you the graphing method just because I prefer that method because I don't like memorizing a formula. So I'm going to show you one more way to do the distance formula. Otherwise, you get to pick. So let's try this again with the graphing method. So if you like the Pythagorean theorem or you like graphing, you're a visual person, you're going to draw a coordinate plane with your x and your y-axis. If you have a sheet of paper, I would copy this down with me on a separate sheet of paper. But you're going to graph the points. So 12, negative 5 would be somewhere to the right 12 and then down 5. Negative 3, 7 would be somewhere to the left 3 and then up 7. So it doesn't have to be perfect, just a rough sketch. After you plot your 2 points, you would draw a line connecting them. So I'm going to draw a line. And then you would create a right triangle out of your graph. The best right triangle I can draw right now. All right, so here is my right triangle. So now I'm going to find the vertical length and the horizontal length. So to look at your horizontal, you're going to take a look at your x values. So horizontal are your x's, vertical is going to be your y's. So from a negative 3 to a 12, I'm going to subtract them. So I'm going to say 12, take away a negative 3. I know these turn into a positive, so 12 plus 3 is 15. So I know this horizontal length is 15 units. Okay? To find your vertical length, you're going to subtract your y values. So I'm going to say 7, take away a negative 5. I know these two are going to change into a plus, so 7 plus 5 is 12. So I know the vertical length is 12 units. Okay? You can also ask yourself, how did they go from a negative 3 to a positive 12? And so from a negative 3 to a 0 is 3 units long, and then from a 0 to a 12 units is 12 more units, hence it's 15 units. Or again, you can ask yourself, how did they go from a 7 all the way to a negative 5? 7 to 0 is 7 units, and then 0 to a negative 5 is 5 more units, hence our 12 units. Notice this 12 and this 15 are the exact same numbers I got here and here. And that will always be true. But now I just do the Pythagorean theorem and do a squared plus b squared equals c squared, which is a little bit less work. So 12 squared plus 15 squared equals c squared. So then you would just type this in the calculator and you get 369 equals c squared. And our last step is to square root, and we would still get 19.2. Okay? So in my opinion, this way is less work, but you do have to be good at graphing and visualizing numbers. If you like the distance formula, because it will always work, and if you like memorizing things, you can use a distance formula. Okay? So at this point, you can use the distance formula, or you can use the Pythagorean theorem to find the distance between 2 points. It is whatever way you prefer, and you get to pick. Okay? So if you have any questions, please let me know. Otherwise, it is time to practice and check your understanding. So I want you guys to try 17, 18, 19, and 20, and then we will go over our answers. On 17, it wants you to find the distance between the 2 points. You can choose the distance formula, or you can choose the Pythagorean theorem, whichever way you prefer. I will show both ways. On 18, it wants you to create a Venn diagram. Remember, a Venn diagram is where you have 2 circles, where you'd have the Pythagorean theorem here, distance formula here. You would write down characteristics that apply to each certain one, and in the middle, you would write down these similarities that they share. Oops. Whoops. Okay, so please try 17, 18, 19, 20, and we'll go over our answers. So press pause, try those on your own. All right, for 17A, you should have gotten the answer of 17 units long. So again, if you got this correct, feel free to not listen to me explain it and skip to the next problem. But I did it both ways. I did the algebraic way on the left and the graphing method on the right. Make sure when you did the algebraic way, you had minus a negative, which turns into a plus sign, which is how we got a positive 15 on that one. On the graphing one, you would graph the 2 points. This one would be in the second quadrant. This point would be in the fourth quadrant. And then you ask yourself the difference between the x values. So you would just subtract them. Or ask yourself, how do you go from a -8 all the way to a +17 or +7, and that's 15 units? How do you go from a +5 to a -3? That's a total of 8 units long. And so you would do 8 squared plus 15 squared equals c squared and square root it. So regardless, you get a distance of an 8 positive value and a distance of a 15 value, and then you square out the final answer. So hopefully that lets you see some similarities between the Pythagorean theorem and the distance formula. Let's take a look at 17b. So on 17b, the answer was 17.07 or 17.1 if you rounded. So here's the algebraic method. Wasn't too bad over here. Just make sure you're subtracting. For the graphing method, again, you would subtract your x values. So an 8 minus a 3 is a 5 units long. So that's the horizontal units. Again, 8 minus 3 is 5 units long. So that was the vertical as well. 5 squared plus 5 squared, 25 plus 25 is 50. So the answer is the square root of 50, or again, 17.1 or 17.07. Okay, if you have any questions finding the distance between 2 points, let me know. Otherwise, we're going to move into some more challenging problems. So I wanted you to create a Venn diagram. So here's an example of mine. You could have many different answers. I put the Pythagorean theorem here, the distance formula here. I said the Pythagorean theorem doesn't have a square root. Maybe you said it, they both have exponents squared in them. For their similarities, I had they both have a relationship between the legs and the hypotenuse of a right triangle. And they also both allow you to find the distance between 2 points. The distance formula, I said it has an extra step of taking the square root, so that it's actually in the formula where it wasn't over here. And then I said the distance formula expresses the lengths of the legs as the difference of the coordinates, hence they're subtracting the coordinates, and that's not represented over here in the Pythagorean theorem. Okay, so you could have had a lot of different answers over here. Here's just an example one. Again, on number 19, it said, suppose you have 2 points lying on the same vertical line. So I just drew an example to help us visualize it. Can you use the distance formula to find the distance between them? Explain. So the answer is yes, you can. You don't necessarily have to, because I kind of did the distance formula to show us with an example number. If you plug in your 4 and your 4, it's going to cancel out. So there's kind of no point in needing that x value if they're in the same vertical line. So it actually ends up only caring about your y values. And so I said, well, if you have a vertical line, you can do a shortened version of the distance formula and only find the square root of your y2 minus y1s. Okay, so an extension problem would be if it is a horizontal line from left to right, the opposite would be true in that I would only need my x values for a horizontal line. Okay, so that was kind of just getting you to think outside the box. Again, if a question ever confuses you, you can always substitute random numbers in to help you kind of figure out the problem. All right, last but not least, said write and simplify a formula for finding the distance d between the origin, which if you forgot is at the coordinate point 0, 0, and some point x, y on the coordinate plane. So I wrote my distance formula. I substituted it in for the second number. You could have substituted in for the first number, but x minus 0 is just going to be x. So that's the same thing as saying x squared plus your y squared. So if you're ever finding the distance between the origin and some point, all you have to do is square your x's and square your y's, and then square root them. Okay? All right, so that is the end of our distance formula lesson. If you have any questions, please let me know. Again, you have 2 ways of finding the distance between 2 points. You can use the algebraic method. You are going to have to memorize this formula. You will not get it on a quiz or a test. Or there is the graphing method using the Pythagorean theorem. It's whatever one you prefer. But thanks for watching, and now you can head and start practicing.